like the easiest way to do this is compare it to its reciprocal, right? Secant of x is the same as 1 over what? The reciprocal of secant is cosine. So isn't this the same as 1 over cosine? Okay, so just like tangent and cotangent, we rewrite them as sine over cosine, you can do the same thing for secant. And you should realize that cosine's in the bottom, just like for tangent, which means secant and tangent are always going to have the same asymptotes. So the same way you find their asymptotes are going to be where cosine equals 0. So, the asymptotes will be for cosine equals 0. And where does cosine equal 0 again? That is x, right? So x equals 0 on the y-axis, right? At pi half and 3 pi and 5 pi. Right? Pi half. So we can say that's at pi halves plus any multiple. Anytime I hit the y-axis, so remember we said we could just say plus pi n, or n is an integer. Right, didn't we write this for tangent? Pi halves plus pi n? Because if I add pi to pi halves, I'll get 3 pi halves, and if I add pi again, I always get back on the y-axis. You could say pi halves plus 2 pi n, 3 pi halves plus 2 pi n, but it's unclear. So we're going to graph, let's graph from negative 2 pi to 2 pi, like we normally do for cosine, so I can show you how this, if you know what cosine looks like, you're going to be able to graph secant really easily. Okay? Ready? Remember when we make our graphs, we always have to label our x and y-axis. If you don't label it, I read it as 1. So if you mean it to be something other than 1, you have to label it. And then we can go ahead and graph our asymptotes. We're going to have asymptotes at every pi half. So every place that I didn't make a number, right? Pi halves. Just pi halves. Negative. My graph are all supposed to look like that. Why didn't I make my asymptote to pi? Because I just wanted to make for 2 pi like we do with cosine. Okay, but you can do your So here's where, if you know what cosine looks like, we can just do the reciprocal of that. So at 0, what is the cosine of 0? 1, and the reciprocal of 1 is still 1, right? So secant is also going to be at 1. Cosine, normally, if you remember cosine, it goes down, right? It's at 0 here, which is why it's going to find on the reciprocal. It goes down like this, right? It comes back up. And we kind of want to flip that over is kind of what we're thinking about. If you want to pick a point just to show you why this works, that would be pi force. What would be the secant of pi force? What would be the cosine of pi force? Third 2 over 2. So the secant of that would be flipping it over, right? And lots of you wrote on your test 2 over square root of 2 with the simplified down. But you can type with your calculator, and you get like 1.4. And think about that for a minute. For cosine, cosine is stuck between -1 and 1. But secant is not, right? It's like the opposite of that. You're flipping it over. So this is going to be like a little bit above 1. And if I go this way, it's going to be the exact same, a little bit above 1. So it's even function. So things are kind of going to look parabola-ish. I don't know if that's a real word, but which means we're going to just follow our asymptotes, and secant's just going to keep getting bigger and bigger and bigger. But very different than tangent and cotangent, it's not the same in every set of asymptotes, because at pi, what is the cosine of pi? It's -1. So it's not going to be exactly the same. It's going to be down here at -1. But do you think it's going to look like that, only down here? It is, because it's going to be the same at 3 pi fourths and at 5 pi fourths is going to be -1.4-ish. And then what do you think is going to happen in the next one? I'm going to draw cosine. You don't do this, okay? This is what cosine looks like. It goes back like this. And it just keeps repeating itself, right? Up, down, up, down, up, down. I like to think of secant as if you know where cosine goes like this, the reciprocal, you can kind of think about it, just flips over and it goes up now. And where this one goes down, you just flip it over and then it just goes down like that. Which means when it comes back to this side, it's this one, if I kept going, would it have another one that goes up? So it's going to go 1 up, 1 down, 1 up, which in this one I only have half of it. So really it would just be this half, because I stopped at 2 pi. But if I kept going, then I'd have the other half there. So it does repeat itself. Yes, you can memorize it, but tangent is the exact same in every one of these, right? And cosine, it takes 2 before it starts repeating itself, because the period is 2 pi, just like cosine. And what's going to happen over here? Go up, and this one's going to go down. I'm probably the most lenient on secant and cosecant, just because as long as you get that point where it's going to go, I always just don't. The cosine graph is not part of the secant graph. I just put it there to show you how you can use that. Secant is really like just a bunch of separated lines. What happens if there's a separate front? Yeah, so instead of starting at 1, if there was a 3 in front of this, that wouldn't start until up at 3, because think about cosine would be between -3 and 3, so it would be above that. The domain of this is exactly like the domain of tangent. It's everywhere but where the asymptotes are. Not the range of it. Yeah, it's like everywhere but -1 to 1, right? It's like the anti-cosine. But like cosine's range is -1 to 1. Secant's range is everywhere but -1 to 1. So we can say -infinity up to -1, including it. And then union, we're going to skip over everything between -1 and 1 and then pick back up at 1 to infinity. Right? That's a cool range. Do you think cosecant's going to look similar? The asymptotes are going to be in different spots because cosecant has sine in the bottom. Super. We can take the period, stretch it, but it's just knowing the shape there. Cosecant is 1 over sine. Cosecant is cotangent. Both have sine and cosine. They both have asymptotes. 5. Where sine equals 0, y equals y. So sine equals 0, y equals 0, so we can say our asymptotes are where sine of x equals 0, which is every multiple of pi, which I'm just going to say is pi times a. So just like the last one, let's make a graph that goes from 2 pi to negative 2 pi. And let's use what we know about sine to know it's going to be these parabola shapes that slopes over from where sine is. 2 pi. And I know there's going to be asymptote at 0, at pi, at 2 pi. I'm going to make those. So just like cotangent, there's going to be an asymptote always at 0. And there's going to be one pi. There's going to be one 2 pi. If sine equals 0 at all of these values, equal 0 at all these. So this is where knowing sine is great. Because what does sine normally look like? Remember? Starts at 0. It goes up to its highest point, back to 0, down to its lowest point, back to 0. Right? Everywhere it's at 0 is my asymptote. So that's an asymptote, asymptote, asymptote. We'll have this same shape. I'm just going to flip it up. So at pi halves, am I still going to get that value of 1? Yes. And then I'm going to flip it up. So it's going to go and I'm going to get all bigger values. At 3 pi halves, I get my lowest point on sine. At 3 pi halves, it's going to go down to negative 1. Right? But instead of being that bottom half there, I'm going to flip it over and I'm going to make it. Yeah, I didn't label it, right? If you don't label it, it means it goes by 1. Just going up to 1 and negative 1. And then if I kept going, what happens after this? It just repeats itself, right? So then it would go back up, and back down, and back up, and back down. Which is why this is one period of cosecant. One parabola up, one parabola down, and then it just repeats itself. And remember that sine is odd, which means over here it should be the opposite. If this one's up, right, this one has to be down. If I said graph 2 periods of cosecant, I just graph 2 periods. Again, we can put a negative in front, which is going to flip up. We can stretch it and make it move up higher or lower. We can change the period, which is going to change the asymptote. Because to me, the most important thing on me is if you get your asymptotes right, and if you know the shape of it, as long as your asymptotes are labeled correctly, you're going to change the value. So let's write this out. The real reason I didn't print your notes because these are all my notes with like so it is yet. I felt like it was so easily. So sometimes it seems kind of overwhelming of how do I remember all these asymptotes, but it's all about whether sine's in the bottom or cosine's in the bottom. So tangent and secant will always have the same asymptotes. So if you have y equals tangent of bx minus b, or you have y equals secant of bx minus c. If I want to find two consecutive asymptotes, These are always going to have the same 2 consecutive, and then you just solve it. And again, how do I remember this? Because secant is 1 over cosine, and because tangent is sine over cosine. So I don't feel like I memorize this. I feel like I think in my head, okay, what's the thought of cosine? Cosine 0 at okay, or you can just memorize it. That every time to find those asymptotes, you're going to set bx minus c. For me, I always do negative pi halves and pi halves. That gives me 2 asymptotes in a row that I normally know. And then if I change the period or I throw in a phase shift, if I solve this, it'll give me my 2 new asymptotes. I am not going to make you graph any by hand with the phase shift, but I am going to make you find 2 consecutive asymptotes. And we're going to do an example like this in just a minute that has a c value. And then the other 2 go together, cosecant and cotangent. So we can also say that y equals cotangent of bx minus c, or y equals cosecant of bx minus c. And maybe instead of remembering that they both have sine at the bottom, both of them have sine at the bottom and sine at the pi, which means to find your 2 consecutive asymptotes, you're going to do bx minus c equals 0, and bx minus c equals pi, and you're going to solve it. When you're graphing, you'll always have 1 at 0 on these, because I'm not going to make you graph any with a phase shift. But the next example, I'm going to use pi. Yeah, on even with the calculator, you're not going to have to graph it. Period change, right? They can move up, I can change the period, I can give an amplitude. But we haven't graphed any with the c value yet, and we're not going to by hand. That's kind of ugly to do. We're going to look at the graphic calculator Friday, and I'll show you how to do it. It's okay, we're doing the phase shift in my math 37 class. They did it, but I don't do it. Alright, you will definitely have questions on your test just like this that say, find 2 consecutive asymptotes of the function. Number 3, we have not ever graphed anything like number 3. We could, it's really not, that one's not such a terrible phase shift. A 4 in front of this means that our period has changed. Now it's 2 pi over 4, so that would be a period of pi halves. This, right, remember phase shift is c over b, so that means that we have shifted this graph by pi fourths. So where it's normally 0, right, it's going to be shifted over pi fourths. So normally secant starts up on the x-axis, so we shift it. And so that's where it gets a little harder to recognize it. You need to throw those phase shifts. What I want you to be able to do is know what you're setting it equal to solve. So secant is cosine to the bottom. What are my asymptotes for the cosine to the bottom? Pi halves and negative pi halves. So I'm going to say 4x minus pi is equal to negative pi halves, and 4x minus pi is equal to pi halves. And then, especially with addition and subtraction, we've got to do the algebra correctly and solve this for x. So if I'm going to solve this for x, I'm going to add pi. And since I have a negative pi halves and a pi, I can add those together because they both have pi in them. And think about, if I have a whole pi and I eat half the pie, how much pi do I have left? It's pi just one pi and then negative half pi. Seem a little dazed out there, buddy. We're dividing by 4 here, right? And so dividing by 4 is the same as multiplying by 1/4. Which means I think we should get that we have an asymptote at pi 8. And that's because of that phase shift. That's why it's kind of a weirder number to get there. Every year, people get an answer, they say pi 8, and then they just say negative pi 8, and they move on to the next question. When you are adding and subtracting, it's not just going to be one positive and one negative, so just be careful, right? Because on this one, when I add pi over, right, now I'm adding pi to pi half, or then pi plus half of pi, pi and a half. Remember, you can always just add the number 1/2 plus 1, put the pi back with it. Right, so it's not just negative pi 8. When I divide by 4, I get 3 pi, which means, if I was going to graph that, that's where 2 of my asymptotes would be. Right, a little bit harder to do when there's adding and subtracting. This one's not so bad. You could graph this. You might have to graph this on your homework today. Cosecant has sine in the bottom, and sine equals 0 at 0 and at pi. So this one's a lot easier, right? 3x equals 0, 3x equals pi. So divide by 3. If there's no phase shift, you'll still always have 0. That's why I like those. So I don't make you graph phase shifts. Divide by 3. That means this one would have a shorter period. Questions about that? One more. Not even a graph. We'll practice with this, right? This is the same questions that you guys had over yesterday's homework. Same stuff on your homework today. If you did your homework yesterday, tonight's homework is exactly the same, except for it's secant and cosecant instead of tangent and cotangent. Notice that I wrote, given the exact answer when possible, but your homework is broken up of when do you use a calculator and when not to use a calculator. I don't know where secant equals 1.2, which means that I know this is a calculator problem. This is really, really important. When I see that it's 0 to 2 pi, how many answers should I be getting? 2 answers. My calculator should give me 1. I have to find the other one. Just like 35 that we did, or whatever number we did together, secant is not a button on my calculator, so you have to flip it first. So secant reciprocal is cosine. Right? So like I said, cosine equals 1 over 1.2. If I'm solving for the angle, I'm using that inverse button. I'm in radian mode. And my calculator should give me an answer. I could already think about what quadrant it should be in. Cosine is positive in quadrant 1. Which means my calculator should give me an answer in quadrant 1. So I'm going to hit in radian mode, inverse cosine of 1 divided by 1.2. And I get an answer of like 0.59. And so this is what I was saying yesterday about the tangent and the cotangent. I always think you should solve picture because you have to think about, depending on what you are using, which quadrant you can be in. So your cosine, what kind of quadrant is cosine positive? Cosine is x. Cosine is x. It's going to be 4, right? X is positive on this side, negative over here. So you have to know what quadrant you're in, and then you got to figure out how to get that angle using reference angles. So this is exactly the same reference angle that I got in quadrant 1. So your job is to figure out how do I measure from here all the way to here. Yeah, it would just be 2 pi minus that angle. So my second answer would be 2 pi minus 0.59. And you should get like 5.6. Right? Not all of the one on the homework, they don't all say 0 to 2 pi, but make sure you look to see what they say. At the beginning of the homework, it's just like yesterday, matching the graphs with the equations, then you have other graphs, then you have tangent, then you have the secant and cosecant. So, day 2, cosecant does. You actually have like, I don't know, almost 10 minutes. Almost 10 minutes. We're going to do a worksheet tomorrow for this, and then I think I have to do a worksheet for 4, 5 is done tomorrow, and then actually I think on Friday we're going to